Okay, so this is lesson 9.6, which is calculating the surface area and volume of a cone. Okay, so first let's annotate the following things on our diagrams. First, let's start by highlighting the radius. Let's go ahead and highlight the radius. What color? Let's go with orange. So the radius of a cylinder is here. The radius is always on the base. And the radius is still here. So our radii are in the same place. The height, which is the distance from base to base. Since there's only one base on a cone, it's going to be from base to apex. This is still called the apex, much like it's the apex in a pyramid. And then we'll go ahead and quickly do the slant height. A cylinder does not have a slant height, just a cone. So this is our slant height, L. Our height is H, and our radius is obviously R. So now we'll sketch each of the pieces. We're going to shade the base and bold its height. Bold the height. So this is the base of our cylinder, and then our height is the pink. Our base is still the circle, and then our height is still the pink. Now we'll sketch each piece. So the base is the circle with a radius of r. So if we have to find base area, it's equal to pi r squared because it's area of a circle. The base for a cone is the same. It's a circle base with a radius r, so the base area is equal to area of a circle, which is pi r squared. Lateral area for a cylinder. We've talked about this a couple times. We've talked about it before, but remember that the lateral area, it is actually a rectangle where this is the height, right? And then this piece is the distance around the base, because that's where the lateral area is like wrapping around, which is the circumference of the base, which is 2 pi r. So to find lateral area, this is a rectangle, so base times height, or length times width, so that would be 2 pi r times h. 2 pi r is the circumference of the base times the height, which is h. So surface area of a cylinder will be the two bases, right? Two of the bases, 1, 2, plus the lateral area, which is that rectangular piece. Volume we've done before, which is base area times height. So it would be the area of the base, which is the circle, times the height. Now let's talk about the cone and how it's different. The lateral area, it's actually very different. It kind of looks, if you were to unwrap it, it looks more like a Pac-Man. Okay, this right here is this. If we were to cut it open, right, then you'd create that. And then this is still actually the distance around the base, but it's kind of a weird shape. So I'm going to go ahead and tell you the formula. Feel free to look it up if you want to. But the formula for lateral area of a cone is pi r times L. So pi times the radius times the slant height. That's how we'll find lateral area of a cone. Again, feel free to look it up if you like to see where that comes from. So surface area will be the one circular base plus the lateral area, which is pi r L. Now volume of a cone, similar to volume of a pyramid, this cone is 1/3 the volume of the cylinder. So it'll be 1/3 base area times height, or volume is base area times height divided by 3. Using that information, let's do these two questions quickly together. Find the surface area and volume of the cone. So surface area will be the base area plus the lateral area. So the base is a circle. So the base area is this guy here. So pi times the radius squared, which is 9 pi. The lateral area is pi times r times L, or pi RL. So pi times the radius, which is 3, times the slant height, which is 7. So that's 21 pi. So the surface area is 9 pi plus 21 pi, which is 30 pi meters squared. Now we're going to go ahead and find volume. Volume is base area times height divided by 3. Remember, our base area, we've already solved for, is 9 pi. The height, distance from apex to base, technically right now we don't know. Okay? But what we do know is that's a right triangle. And we don't know the height, so it'll be height squared plus 3 squared equals 7 squared, using Pythagorean theorem. H squared plus 9 equals 49. Subtract 9 on both sides. H squared equals 40. Square root both sides. H equals the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So the height is actually 2 square root 10. Divided by 3. We can reduce, so this reduces to 3. 3 times 2 is 6 pi square root 10 meters cubed. Unfortunately, that is as far as we can go. Alright, last problem. The volume of a right cone is 12 pi feet squared. So volume is 12 pi. And the radius is 3 feet. Find the approximate surface area of the cone. So we're actually solving for surface area. So if we want surface area, there's a lot of different pieces that go to that, right? Let's draw a picture. It's a cone. So we know the radius is 3. In order to find surface area, we'd need base area plus the lateral area. So the base area we can do, pi times the radius squared, plus the lateral area, which is pi times the radius, times the slant height, which right now we don't know. So we need the slant height in order to find the surface area. So let's use our volume formula. Volume equals base area times height divided by 3. So it'll be pi times the radius squared times the height, which we don't know, divided by 3, and that equals the volume, which is 12 pi. Simplify one step. Let's reduce this. 12 pi equals 3 pi times h. We're going to solve for h by dividing both sides by 3 pi. And 4 equals h. So we actually know that the height of this is 4. We found that from the volume formula, which is nice because this is a right triangle. 3, 4, and so that means that this is 5. The slant height is actually 5. Now we have everything we need to find the surface area. 15 pi. So the surface area is 9 plus 15, which is 21 pi. And we want the approximate So we're going to multiply by 3. Surface area is approximately 63 feet squared. Remember, you can always go back and rewind, pause, and replay videos.